Hi folks, welcome to another episode of NYC CNC. We're going to be starting some CNC-based projects using Arduinos. I'm really excited. I'll tell you about them in a second. What we first need to do is establish a groundwork. We're going to use the GRBL Shield, and to do that, we've got to go through some steps to set that up and get those working. Two of the most popular videos we've done on the channel were how to drive large stepper motors with an Arduino, and then how to test some of the accuracy you can get with an Arduino and a stepper. We actually hooked up some machinist measuring tools and got some amazing precision out of steppers. So there's no question that steppers are an awesome way to automate, mechanize, control Arduinos, to do it very precisely, and they're fun. The projects that we've got going are two different ones. One is I'm so excited for. We're going to combine machine products with Arduinos, steppers, automation, and guns. We're going to try, we'll see how it works, we're going to try to build an output device for a reloading press. What it's going to do is it's going to be a little feed tube that will rest over either a 50 round or a 100 round ammunition box, and it's going to automatically put your ammo in the box. This has multiple purposes. It's organized. If you have a problem with your ammunition, you can see where maybe one went bad. You can flip it right into a case gauge. We'll talk about that more in that video, but that's sort of the goal. The other project, I just did a video series on the fixture I made to engrave our Saunders Machine Works hitch covers, and what occurred to me is the real right way to do this is a plate engraver. You can purchase plate engravers for plasma machines. I don't love my plasma. I've been thinking about changing that up, so I don't want to commit $2,000 or $3,000 to a plate engraver for it. So I thought, let's make our own plate engraver. So we're going to use Arduino, linear motion equipment, and guide rails and linear rails and carriage blocks, and a pneumatic engraver to build an Arduino-based metal pneumatic CNC engraver. Should be awesome. So let's get right into the GRBL stuff and get you guys set up so that you can run your own GRBL as well. Let's quickly review the hardware you need. We need a power supply. You're going to want something that's more than 12 volts. This one is 24 volts, which is great. Some folks also use a benchtop power supply. It needs to be able to have current rating to hold the combined current of the three steppers you're using. This one happens to be 25 amps. That's more than you need. I would go with at least 10 or 15. There's a link below for not only the power supply, but all of this hardware you need in the video description. I've got a few different size stepper motors. I'm going to go into the size requirements for steppers and the power supply and so forth and current ratings in my next videos on the actual projects. Today we're just going to focus on getting up and running. So these are very similar to what you would see on 3D printers. We've got an Arduino Uno underneath the shield here, and the shield is the GRBL Shield. And then just an FYI, this back third stepper here happens to be connected to a timing belt. Not necessary, just what I had set up for another project. Now let's take a quick look at how you hook up the steppers. Let's unhook one of these steppers and I'll show you how to find the pair. If your data sheet or manufacturer vendor tells you which coil pairs they are, that's great. Otherwise, you need to have the first two pins be a pair and the second two pins be a pair. Okay, so we've got ourselves a stepper. All you need to do to find the pair, which two are the pairs, spin this motor with your index finger and get a feel for how hard it spins. I happen to know that the black the green are a pair. I've already done this. So hold them together so the wires short out and spin that, and you'll find that when the coils are shorted together to natural resistance or break, it's much harder to spin. You can still spin it, but much harder. So if I let go, much easier. You can also use a multimeter on the ohm setting. It should be a relatively small amount of ohms, so put it on the 200 if you're using this meter, and this meter is absolutely my favorite inexpensive multimeter. There's a link in the video description, 14 bucks off of Amazon. Hard to beat it. It's been my go-to meter for over 4 years for just around the shop and house and so forth. So how do we get this to work? The first thing we need to do, we need to upload the GRBL software onto the Arduino hardware. GRBL isn't just like an Arduino sketch that you can open in the Arduino IDE. We actually have to add this hex file. So again, link in the video description. I've been actually working with version 8 for no good reason other than that's what I've been with. I need to upgrade to version 9, and I'll do so and talk about that in the, again, project videos coming up soon. So you download this hex file, save that to your desktop. Then go to this website, again, link in description, and download this little program called Xloader. Open that program up. You see I've got it open right here. Navigate to that hex file. Again, here is the one I'm using right here. And then device, you need to be using a 328. The old ones, whatever, the 68 Arduinos won't work, but those are quite old nowadays. That's odd, they have one listed here, but I don't think they work. Anyways, I've got an Uno with a 328, and that's the Arduino that's in the video description link. And the COM port and baud rate I didn't change. And click upload. What that's going to do is it's going to flash this hex file to the Arduino, and I can't tell you more other than it works. So now, before you connect your shield to the Arduino, go ahead and you may be finished watching this video, but before you start hooking stuff up, read this page. Again, link in the description, using GRBL Shield. There's some really important things. The biggest thing that's important is that there's 2 power terminal lugs on the GRBL Shield. You cannot reverse those, the positive and negative, or you will fry the shield and it's basically trash. I think they'll repair it for a fee, but consider it wasted and you're done for the day. So read through this, check the polarity twice, big boy rules. I'm going to let you guys spend the time you need to get comfortable. Walk through the same finding the stepper motor coils that I just mentioned. Lots of other good stuff there. So connect your GRBL Shield to the Arduino, open up the IDE, and then power on your power supply that's going to give power to the GRBL Shield. Okay, take a quick peek. We've got COM12 as a port. Now open up the serial monitor. What you should see is that. You may say 0.9 if you're using 0.9. We'll type in the $ and hit enter, and we'll get some strings back. Now, if hitting enter didn't work for you, make sure you have this both NL and CR for new line and carriage return checked. And that means our GRBL is working. So if we hit star or $, we see all the current settings. We'll get back to this in a minute. But that's great news. That means you are pretty much good to go. Now, you could use an Arduino to stream basic things, and in fact, even if we type in right here some G code, G01X5F20, we get movement. But we obviously don't want to just type in line at a time. We want to stream the G code. So now what you want to do is go to this link and download the software called Universal G-Code Sender, which is going to be a little Java program, a little bit different than your normal Windows type program. I'll show you right now. So I have it in my GRBL Shield folder, Universal G-Code Sender, and the jar file is the executable. And look at this, we get this little GUI here. Now, we know COM12 is our Arduino, and we're at 9600. You can click refresh if you need to see it, and we'll click open, and boom, there we go, connected, and you get that same, hey, I see the shield, which is great. So same thing, we could enter in individual G-code commands here, or we can open up a file, and if we click browse, I've got a sample file. I think it's sort of garbage, but if you click visualize, it does sort of a back plot, which is pretty cool. We'll get more into this later. But most importantly, you can click send, and we're in business, folks. That's awesome. You can see right here, we are streaming G-code. It's showing the position of the work and the machine. And you can, when this is finished, I'll show you, you can come into machine control and you can jog. There's some pretty powerful stuff that I'll be honest, I haven't even gotten into yet. But again, I wanted to put this video out because I want folks to be able to see just how easy it is to use an Arduino, really inexpensive, and a GRBL Shield to do some pretty cool stepper stuff with Arduinos. Okay, we've got one more thing to cover today, and it's one of the most important things. When we hit $, we see all the settings. And if we look at the first few, they say X, Y, and Z. They are all 250 steps per millimeter. So that presupposes you already have a lead screw hooked up, the lead screw being what generates the millimeter of distance traveled. Right now we're just running bare steppers with no lead screws attached. So we'll cover more of this when we start building an actual project and we pick a pitched lead screw. But for now, I want to make sure these are working correctly. So here's some very simple math that confirms that. The 2 steppers that we're using, this guy here and the one back here, are 200 steps per revolution. Now, the boards, when they're shipped from Synthetos, whatever that company's called, are default to 8 micro steps, and you can see here on the little cheat sheet on the circuit board itself, if there's no jumper here, it's set at 8. So micro steps mean it is 8 per step itself. So you have 1,600 total steps per revolution of the axle of the stepper. Now, if we're saying 250 steps is 1 millimeter, then how many millimeters do we need to go for 1 revolution? Well, it's simply 250 divided by 1,600. That means we technically need to say go 6.4 millimeters and we should get 1 rev. So conveniently, we've got this here at about 9 o'clock. Let's go ahead and in our program, command G0, now let's see, that's hooked up to the Y. So G01, Y, hold on, I need to reset everything to 0. There we go. G01, Y, 6.4. Boom, check that out. Just to make sure, let's go 5 revolutions and just make sure we're still okay. So that should be 32. I'm gonna go ahead and reset 0 again. G01, Y, 32. 1, 2, 3, 4. Should end up at 9 o'clock right now. Perfect. Now, last but not least, this bigger guy happens to be 400 steps per revolution. So if we look at the same math, that means 1 revolution should be 12.8. It's hooked up to the Z-axis, so let's go G01, Z, 12.8, and let's see if we end up right back here. Perfect. Awesome. Now, let's just check the micro stepping. It's defaulted to 8 because there's no jumper. Let's add the jumper on the first, let's see here, the first one should be 2x, like so. Now we'll go from 8 to 2. Now it should only take 3.2 to go 1 revolution. So I'm going to return to 0, G01, Z 3.2. Look at that. I think that's pretty cool, folks. So that's a wrap for today's lesson. Hopefully that's a great framework. Hopefully that tells you what you guys need to know to get started with GRBL. Again, some really cool things to come. If you're interested in this kind of stuff, please subscribe. Like I said, we're working on a pneumatic project. We're working on a CNC dispenser project, some really cool linear rail stuff, all that good stuff. So appreciate your time, folks. Take care, and I will see you soon.